Okay, so today we're going to be talking about finding domain and range from discrete and continuous functions. So the first problem is about batting cages. It says you're at a sports center that has batting cages. The number of pitches P, so P stands for pitches, you can get for T tokens, so T stands for tokens, is given by the function P equals 10T. So part A is asking, is this a discrete or continuous function? So the way you can tell the difference is if you can have half of whatever the variable is in your equation, then it's going to be continuous. But if you cannot have in-betweens, then it's going to be discrete. So can you have half of a token when you go to a batting cage? No, you can't have those. So it's going to be what? Discrete, since you can't have half. And what we know about discrete graphs is that when we plot those points, we do not connect those. So if you have 3 tokens, they want you to graph it. So we're going to graph it right here in this first one. So if I have 0 tokens, how many pitches can I get? 0 pitches. So I'm just plugging those into this equation right here. If I have 1 token, how many pitches can I get? If I have 2, and if I have 3, good. And do I connect these? No, because it's discrete. You can't have half of a token, so we don't connect those. So we're done with that part. Now, what is the domain? Whenever we're talking about domain, we're talking about the x. So looking at just the x-axis, we can't have any in between. So what you want to do for discrete, and you'll always do this, is you're going to list out every single number. So you have 0, you have 1, 2, and 3. So you're literally going to write out 0, 1, 2, and 3. 0, oh, wrong spot. 0, 1, 2, and 3. Now you need some kind of indicator of this is where I'm starting my list and this is where I'm ending. We use the curly brackets, which we call mustaches in this class. So go ahead and draw those in. Now when we talk about range, what are we referring to?
Y.
The y. And I'm going to list those as well. Now I have 0, I have 10, and when I'm done, I need to close it. So like that. What is the greatest number of pitches you can get for your tokens for this problem here? 30. Because you only have 3 tokens. So now it says, suppose you have 5 tokens. They want you to graph it over here. That'll be the max, but hold on, let's graph it first. So for 0 tokens, then for 1 token, for 2, 3, 4, and 5. Good. Do I need to connect those? No, because it's discrete. Good. So now they want to know what is the domain. I'm going to move this up a little. Good, but you forgot the first number, the 0. Because it is possible to have 0 tokens. And I need an indicator of starting and stopping. Your range. Good. So what is the greatest number of pitches you can get from your tokens? 50. So far so good? Okay. Any questions with that problem? No. We knew it was discrete because you can't have half or a quarter of a token. So let's look at the next one. I'll give you a minute to read it on your own. And then we'll read it together and we'll underline all the important information. Okay, so this problem is about renting a bicycle. a bicycle rental shop rents bicycles for $8 per hour. And we know the word per means to do what? Multiply. Good. The total cost C, so total cost is C, and we're talking about dollars, for renting a bicycle H hours, so H stands for hours, is given by the function C equals 8H. So what we highlighted at the very beginning, that's the formula right there, the equation. Once you get to the rental shop, you figure you can rent a bicycle for at most 5 hours. So now they're giving you restraints, like you can only go up to this. So is that function going to be continuous or discrete? Before you answer, think, can you have an in-between, like the hours? Can you rent a bike for half an hour? Yes. So if you can do a part of it, but not also the whole, then it's going to be continuous, because you can get half an hour. You can rent a bike for an hour and 10 minutes. So that's going to be continuous. They want us to graph the function. So I'm going to move this up a little bit. So if I rent it for 0 hours, how much do I have to pay? And if I rent it for 1 hour, so put a dot there, for 2 hours, and remember, all you're doing is you're plugging in these x values into that equation right there. So for 3 hours, 24, good. For 4 hours, 32. And for the 5 hours, 40. Now remember, we said it was continuous, so we need to connect. Good. So do the best you can. Do I put an arrow at the end? If the max I can rent is for 5 hours, no, you can't put an arrow at the end. So we graphed it, we're good. Now domain. It's going to be a little bit different than how we listed it above, because now we have the in-betweens. So instead of listing out 0 hours, 10 minutes, 20 minutes, 30 minutes, and all the numbers in between, and we can even take it to seconds, that would be a long list. So what you want to do is you want to use your inequalities. When we talk about domain, we're talking about X or Y? X, good. So looking at our X, what is the furthest left this graph goes? Left. 0. And the furthest right is? Good. So 0 to 5. Is it okay if we rent the bike for 0 hours, if we don't rent it at all? So we're going to underline it. And is it okay if we rent it for exactly 5 hours? So do I underline it? Good. When we talk about range, we're going to put our inequalities, our alligators. And remember, those little alligators, the inequalities always open up the same way. So range is from bottom to top, 0 to 40. And I'll underline those also. So domain goes from left to right, and range goes from bottom to top. And that will never change. So how much will it cost to rent a bike for 3 hours? I can do one of two things. I can either go to my graph and then see where it crosses, or I can plug it into that equation and get what? Good. Now, if I want to rent the bike for 2.5 hours, I can do the same thing. I can either go up at half, or I can plug it into that equation. And if you do that, what do you get? 20. Good. So what is the most you will pay for renting this bike? 40. Good. Because it's for 5 hours at most. So now we're going to change this graph a little bit. Let's say the bike renting company, instead of charging you $8 per hour, wants to charge you $10 per hour instead. What's going to happen to the rate? What's going to happen to your slope? how? Is it going to increase or decrease? Increase. So I'm going to put M because M stands for slope. So M increases. And how would the graph change? So if I was doing $10 instead, the brown is showing that one, it's going to become steeper. Good. Anytime your line is becoming more and more vertical, straight up and down, that's considered steeper. So I'm going to change colors, and we'll do the last one for the front, and then we'll go to the back. So the last one says, what if there was a non-refundable deposit of $5 charged to all rentals? So this is like your initial fee. And we know anything that's talking about a starting point or an initial is considered what? Your y-intercept. So everything is going to be moved up. So if we move everything up and we're comparing this green line to the blue line, will those two lines ever touch? No. So what will happen, goes that way, there'll be parallel lines, but if we were to compare it, their same slope, still going to be going up by 8, up 8 over 1, it's just now moved up 5. So our y-intercept is equal to 5 when it was 0, and we move the graph up. So far so good? Okay, so now we're going to go to the next problem. The green? Okay. So the equation for green was the same one that we originally started with. C is equal to 8h, but our y-intercept here, since there was no number, it was automatically a 0. Now we changed it to what? So all I did was put a plus 5 at the end. And then I graphed it. So I just shifted everything from that blue line up 5. Okay, because now we have a deposit fee. So let's look at the next problem. And this one we're going to have to label the graph ourselves. So I'm going to zoom out a little bit. It's talking about losing water. So it says a tub is filled with 15 gallons of water. So that's like your initial amount. And anything that's initial is considered our what? Good. Our y-intercept. And is losing 1 gallon every hour. And the key word there is every. So we know that's going to be our slope. Good. So they want us to write a function for the amount of water left in the tub after X hours. So hours are now X. So how would that equation look? We would start with y equals how much water's in the gallon or in the tub already? So 15. And then 1x, and we're losing it. So is it going to be adding or subtracting? Subtracting, since we're losing. Now another way of saying y is f of x, since we're using x here. So I'm just going to rewrite it like that. So is this function discrete or continuous? Now anytime we talk about hours, we can have minutes. That's okay. So it's going to be continuous. Anytime you see like time intervals, unless it specifically says like we're only going by hours or we're only going by minutes, it will always be continuous. So now they want you to label the coordinate plane and graph the function, and then we're going to identify the domain and range. So if we counted our blocks going on the x and on the y-axis, we have about 17. So we can go by 1 for this one. So this is always 0. And then I'm just going to label every other box. So that's 1, 2, 3, 4. Okay. Are we ready to label the other one? The y? Okay. So I'm going to do the same thing. I'm up by 1, but I'm only going to write every other number. So, just so I have room, we can read it. Okay. So, if we're going to graph this, whenever I'm going to graph an equation, do I start with the slope or the y-intercept? The y-intercept. In this case, our y-intercept is 15. It's always the number without the variable. So I'm going to start with a positive 15. My slope is negative 1. So I'm going to go down how many? And to the right. And then I'm going to keep doing this until I run out of room. We said this graph was continuous, so what do I need to do after I plot all the points? Go ahead and connect all of those. Because it's okay to have, half hours and stuff like that. So if I do that, the only thing I'm missing is labeling. X stood for what? It says it right here. Hours, right? And what does our y-axis stand for? Gallons of water. And I'm just going to write gallons for right now. Alright, so let's move this paper so we can see it. So now we need to discuss the domain and range. It is going to be a continuous function, so am I going to use my alligators or am I going to list everything? Alligators. So for domain, we'll talk about x. How far left does this graph go? 0. And how far right? Double check it. 15. And it's okay to have both of those, so we're going to underline. Where our range talks about the y. So I'll have my inequalities. How far down does it go? And all the way up to 15. And I'll underline those as well. Alright, so now they want you to describe the meaning of the y-intercept. So what is going on right here? It started. What is started? It's the initial amount of water inside the tub, right? So that's what we're going to write. The initial amount of, and I'm going to put H2O for water, of water in the tub before it decreases. Or before we start losing it, however you want to say it. Okay?